Hello and welcome to the first module in our C language series. In today's session, we're going to start with a brief introduction to the language, and then we'll focus on learning just one function, that's the printf function. So just to give you a brief history of the language, C was created by Dennis Ritchie in Bell Laboratories. Before C, there was a language called BCPL, or Basic Combined Programming Language. Now, of course, this language is no longer commonly in use, but has left its influence because of the creation of a language called B. Now, C was originally created for programming under Unix. A little bit about Unix here. Unix, as you may know, was originally written in assembly language, but was moved to C because C was found to be more compact in terms of requiring lesser number of lines of code. And C allowed for Unix to be portable, which means it could be used across different processors. C is a structured language, the main structural component being a function. Now, what do we mean by C is compiler based? You may be aware that computers understand only one language, that is machine language, and any code we write needs to be translated into machine language. There are two kinds of software that do this job. One is the compiler, the other is the interpreter. C uses a compiler. If you worked with Python, then you know Python uses an interpreter. Now, C is a very powerful language and a middle level language. Why is it very powerful? Because it allows us to work with bits and bytes. Now, what's a bit? So any 1 or 0 that you see here constitutes a bit or a binary digit. Computers follow the binary numbering system. Why? Because remember, computers are electronic devices, and the only thing they can understand is a switch being on or off. So every character you see on your keyboard is represented using a series of ones and zeros. In essence, that is what is machine language. Now, why is C a middle level language? Let's look at an illustration here. We have the computer hardware, and we're specifically referring to the computer processor here. The languages that work very closely with the processor are called low-level languages. So here you will find assembly and machine language. Just next to those low-level languages sits C. So C sits between low-level languages and high-level languages, which, by the way, are so called because they are very close to the languages we as humans understand. Right? So as you can see from this illustration, low level means closer to computer hardware, more difficult for us humans to read and understand. High level is easier for humans to read and understand. Moving on to the form of a C program, every C program must have a main function. Why? Because the main function indicates the starting point of execution for every C program. Now, it's not necessary that the main function be the first function in your program, but your program must have a function called main. All program statements must end with a semicolon. This is particularly important if you're coming from a programming background where you didn't have to use semicolons. C is very strict on the use of semicolons. All statements within a code block must be enclosed within curly braces. Here's an interesting piece of trivia for you. The first language to use curly braces was BCPL. And therefore, BCPL is commonly called the first brace language. Now, coming to the printf function. The printf function allows us to print characters. That would be any number, letter, or special symbol you see on your keyboard. Strings, which would be combinations of any of these characters. Numbers, which could be integers, decimals, etc. Variables. Now, when we're talking about variables, we need to have a basic idea of how computer memory works. Right? So we're not going to go into the details, but just to give you a basic idea. So consider computer memory to be like a grid, just like this, with each of the boxes on the grid being or representing a memory address. So variables can be used to give names to these addresses. So for example, I could have the variable x storing the value 10 at this address, and then I could have a variable named fruit storing the value apple starting from this address. Right, so we'll go more into computer memory as we progress through the series. Coming to now the IDE, or Integrated Development Environment, we're going to be using in order to key in our programs as well as compile and run them. We're going to be using code blocks, and we will be looking to download a file mingwsetup.exe. Why? Because this will give us access to the GCC compiler, which is a compiler we're going to use throughout the series. Now, about compilers, there are many available. Some of them need to be paid for in terms of a license, but the GCC compiler is free. Right, so the next thing we need to do is write a C program. But of course, before that, we need to download the IDE. So let's go now to our browser. And this is the page we need. To get to this page, in your browser, just type in code blocks, download. Right? And we click on binary releases. And that brings us to the same page you saw earlier. Right, now we've got Windows here, the options for downloading, that is in terms of Windows. And if you read here, you see code blocks 2003 MingW setup includes additionally the GCC compiler. And so we need to download that. Now, when you see 32-bit, right, what this is referring to is your system configuration. Now, to determine whether your computer system is a 64-bit or 32-bit, all you need to do is just type in system info here, click open, and then you will see system type where it will specify whether it's 64 or 32. And then accordingly, you can download the relevant version. Now, the one I downloaded was this one, right? And I use SourceForge. You can do the same, provided, of course, you have a 64-bit configuration on your machine. When you click on this link, a file will start downloading, which is the MingW setup file. That will be seen in your downloads folder. Click on that file. It's an executable or .exe file, and the installation of your IDE should begin. Now, since I have already downloaded code blocks while your installation is in progress, what I'm going to do is I'm going to go to code blocks and I'm going to type in a very simple one-line C program. What I suggest is that we have all our C programs in one folder. It helps to keep things in order, right? And also makes future reference easier. So now what we need to do is click on File, click New, and then click on File with 3 dots. Double click on C++ source, click Next. Leave this as is because we're working on C. Click Next. And now we need to specify file name with full path. Click on the 3 dots. You'll see I'm taken directly into the folder I created earlier. You may land in the documents folder or some other folder, at which point you can create a new folder clicking on that icon. Right, so I'm going to type in proc1. This is going to be a very simple C program. Click finish. And the first thing we'll do is type in main. We need a main function and we need curly braces, because all program statements within a code block must be enclosed within curly braces. The code block here being the function. So printf, we need a string, so we're going to use double quotes. Welcome to the world of C. A semicolon after that. And now we can use this icon to build and run. So this will take care of compilation and execution as well. So you can see the message printed out. You can see process return 0, which means our execution was successful. Press any key to continue closes this window. If you look down here, we have two warnings. Return type defaults to int. What the compiler is telling us is that main by default returns an integer, and so we need to specify as such. Just type int there, and that takes care of that warning. The next one says implicit declaration of function printf. Now printf has already been defined. It has already been written for us and resides in a file within the standard C library. So we need to specify where it is coming from, and we do that by just typing in here hashtag include angle bracket, that's your lesser than symbol, stdio or standard input output dot h. Close the bracket. Note there's no semicolon because this is not a statement within a code block. Now if we run this, we should have no errors or warnings. Right, so I hope that's clear. Now what if I had to use single quotes? Let's try to run this, and we get two warnings. Character constant too long for its type, right? And then we have passing argument 1 of printf makes pointer from integer without a cast. That's what's written in these three dots. And also you can see process return a negative number, which means execution was not successful. So let's close this window, press any key. To take care of the first warning, the compiler is telling us here that we are passing in a character constant, but it's too long for the type. What is it saying? That when we're using single quotes, we're indicating we are passing a character to printf, but here we have way too many. So we'll pass in just one. And that should take care of that warning. Now the second warning, passing argument 1 of printf makes pointer from integer without a cast. We're not going to go into casts and pointers today. That's for a different session. But we can resolve this warning by using what is called a format command. We specify the type that we are printing out here. So type specification %C would indicate we are printing out a character. And that's all. This should take care of both warnings. You can see no errors or warnings, and the letters printed out. I could also use a %S as my format command, which stands for string, but then I will have to use double quotes. This too will work. Why? Because here I'm telling the compiler, yes, I'm passing in a string, but the string has only one character. There is yet another format command, this %D, which indicates that I want to print out the numerical equivalent of C. Where is this numerical equivalent going to come from? Let me print it out first on screen. So you can see the number 67, and this is the value as per the ASCII table. So if you don't already know, you can Google it, right? You will see the ASCII table and you will see the value for C is 67. If I change the letter to A, then I will get a 65. Right, so that comes from the ASCII table. Now I hope your installation is complete so that we can go ahead and type in our first C program. This is a program we need to write code to print the following with double spacing in between printed lines. So 1 star, 2 blank lines, 3 stars, 2 blank lines, and so on. So we need how many printf statements? We need 8. So let's now go ahead and I'm going to start code blocks again so that you can do it along with me. Let's close this down. Go to your search bar, type in code blocks. Click open. And as I said, the first step is to create a separate folder where all your C programs will reside. So click first on File, click New, then click File with 3 dots. Double click on C++ source. Click Next. Leave this as is because we're working with C. Click Next again. Click on these 3 dots. Now you can see I've come directly into the folder I created. To create a new folder, click on this particular icon, right? And then of course, once the folder is created, you can put in the file name. I'm going to call it proc2. You can call it whatever you like, save the file and finish. So we'll start with hashtag include stdio.h int main and the curly braces. Make sure you have both opening and closing curly braces. Now, the first printf is going to print one character. So printf %c, comma, single quotes and the star. Semicolon. Next one is printf. This time it's a string. So %s and comma, 3 stars. And then printf %s, comma, 5 stars. And then printf %s and comma, 7 stars. How do we take care of double spacing though? Because if I run this as is, you see all stars are printed out in one line. So here we need to use / character constants. We're going to use a new line, character constant, which is \n. So 2 \n's will give us 2 blank lines, right? Include them in all. Now if we run this, you will see that's printed out nicely. Now for the rest, we can just copy. So copy this line first, Control-C and Control-V, then 5, Control-C and Control-V. Right, so now we can copy 3, Control-C and then Control-V. Make sure all lines of code are nicely lined up there. And the last, Control-C, Control-V. Again, make sure all lines of code are properly lined up. This makes for easy readability. Now run it. And there we have the output as desired. Now I have a question. Do we need to have 8 printf statements? Can we do this with just 2 printf statements? And the answer is yes, we can. So the first one, %c \n \n, we can then say %s \n %s \n. So we've got 1, 3, 5. And the last one, %s \n \n. And then we specify the stars here. So 1, 3, 5 and comma 7. Now we can safely delete these lines, we don't need them. And for the next one, again we can keep this for 7 and then %s for 5, %s for 3, and %s, oh sorry, %c for 1. Okay, so we have 7, 5, 3 and 1. And then of course we put in the asterisk or the stars, so 7, 5, and then 3, and then just the 1 star within single quotes, and then delete these lines. Now if I run this, there we have it. Can you do it in one statement? I'm sure you can. Try it out. I don't think you'll have a problem there. If you do, post in the comments and I'll help you out. Right, moving on to the next part of our session, which is a little deeper discussion on variables. So variables have certain rules. All variables must be declared before they are used. So we cannot just say x equal to 10. We have to declare the type of variable x is going to be. Is it going to be a character? Is it going to be an integer, etc., etc.? All variable names must begin with a letter. They cannot begin with a number or a special symbol. They cannot be keywords, meaning we cannot have a variable named printf or int, for example. Lowercase is different from uppercase. So if I have a variable uppercase x or capital X as you know it, and if I have another x but it's lowercase or small x, then those two are treated differently. They'll be treated as two separate variables. Are these variable names valid? The first one, it's not valid because that's a keyword. What about the second one? Again, this is not valid because it starts with a number. The third one, hashtag is a special symbol, that's not allowed, so that's invalid. Period, full stop. Full stops and commas are not allowed, so again that's invalid. Test 1, 2, 3 is valid because it starts with a letter and then combinations of letters and numbers are allowed. The next one again is valid because underscores are allowed in variable names. And the last one again is invalid because spaces are not allowed in variable names. Right. This is the last part of the session. Write a simple C program using variables. Store the value 100 in variable A, store the value 200 in variable B, and print out the message. So we need to first decide the type of variable that A and B are going to be. So here we see 100 is an integer, right? It doesn't have any decimals, so we can safely use integer as declaration. Let's go back to code blocks. Start a new file, file, new, click on 3 dots, double click on C, C++ source, click next, leave this as is, click next again, click on the 3 dots and give a name to your file. Click save and finish. Right, we start with hashtag include stdio.h, then int main, curly braces, and we can say int a semicolon and then int b semicolon, or we can do that in one line of code, int a comma b, which is preferable. Why? Because lesser number of lines of code means more compact code. And now a equal to 100, b equal to 200. printf the value stored in A is %d and the value stored in B is %d, comma A, comma B, right? Semicolon and run. No errors or warnings. And the value stored in A is 100, the value stored in B is 200. Note that we cannot have B, comma A here, because what will happen then is we will see a message definitely, but the values will be wrong. It says the value stored in A is 200 and the value stored in B is 100, which is not the case, right? Therefore, we got to be careful what we put here, because whatever we put in the first place will go into the first %d position, and whatever we put in the second place will go into the second %d position, right? So this now ends our session for today. In the next session, we'll talk about C expressions. It's going to get more involved from now on, but also more exciting. So I hope to see you next week. Till then, take care, stay safe. Bye.